Alright, so for the previous video, we already stopped at the part where we actually completing the square to find out the vertex of the quadratic expression. Okay, so for this video, we are going to continue with the nature of the roots for a quadratic equation. Okay, so again, let's have a look here. What's our learning outcome for today? So the learning outcome for this video is actually you need to find the discriminant of a quadratic polynomial and use the discriminant to determine how many roots do you have, and also at least you know what is the nature of the roots. Okay, so what's the meaning of roots here? So the roots here means that when you let the quadratic equation equals to 0, what is the value of x, right? I think I told you this word before. So this is the meaning of the root. Yeah. So what is discriminant? So discriminant generally is expression which is b squared minus 4ac. Okay, sorry for that. Okay, so it is actually b squared minus 4ac. So you have to know when they mention the word discriminant, a quadratic polynomial or quadratic expression, generally it means b squared minus 4ac. Okay, so let's have a look into the details now. Okay, the nature of the quadratic polynomial is determined by the expression b squared minus 4ac, which is known as discriminant. Alright, so why we actually can decide the nature of roots by using this expression here? Okay, so the reason is because of when you try to solve the quadratic equation, right, by using the quadratic formula, the b squared minus 4ac actually appears here in your formula. Can you see the b squared minus 4ac on top? There. Alright, so now I will try to link this formula with the discriminant concept that we are learning here so that you can link them together. Alright, so there are three types of roots. Okay, for quadratic equation. The first one is b squared minus 4ac greater than 0. You didn't see any equal sign, right? b squared minus 4ac greater than 0, which is positive value. We call the roots as real and different roots. Okay, so what is the meaning for real and different roots? Okay, and then why b squared minus 4ac greater than 0, then we will have the real and different roots. So again, I will take this as example. Maybe I simply put in some number. Let's say your b is -4. Let's say then plus minus. Okay, when they say b squared minus 4ac is greater than 0, maybe I put a number which is more than 0. Let's say I put in a 9. b squared minus 4ac equals to 9. It means it is more than 0, correct or not? Then I simply put in number 2. Okay, so if you look at here, what do you have? -4 plus minus 3 divided by 2. And you can separate your next step into -4 plus 3 divided by 2. And also -4 minus 3 divided by 2. And therefore you're having -1 over 2 and -7 over 2. So these two are the roots of the expression that you have for the quadratic expression. Okay, so when you're having two roots here, we call them as real and different roots. Real means that these two numbers exist, right? It is not square root -4 and so on. So it exists. Therefore, they are real. And different. Different means these two values are different. Therefore, we call them as real and different roots. Okay, so this is why when b squared minus 4ac greater than 0, our conclusion is real and different roots. So you don't need to purposely go and find out the value of the roots. Okay, you just need to look at the value for b squared minus 4ac, then you roughly know, okay, this case belongs to real and different roots. Okay, and then when you are having this kind of graph, this real and different roots, generally your quadratic graph will look something like this. If it is a U shape, it will look something like this, which means your quadratic equation actually cut the x-axis at two different points. So all these values, we call them as root. Therefore, real and different roots also means that your graph will look something like this, okay, where you have two x-intercept, which is different, okay? And then after that, also you are having, if let's say you're having the N shape, so your graph for quadratic might look something like this. This is just a very simple example, okay? Just a very rough idea. So you will see that no matter how it will cut through the x-axis twice. And that's why we call it as real and different roots. All these are the roots. Okay? So this is the first case that we have. Alright, so if we continue to second case, when they are talking about b squared minus 4ac equals to 0. Okay, so for this, when the b squared minus 4ac equals to 0, we call it as we are having the real and equal roots. Equal. Just now it's different, right? So now it's equal. Okay, so what does it mean? Again, if you look at the quadratic formula, let's say x equals to -4 plus minus, okay, b squared minus 4ac, they let it equals to 0. That means I'm having a 0 here, divided by 2a, let's say, okay. So what do I have from here? I have -4 plus minus 0 divided by 2. Okay, then -4 plus 0 divided by 2. -4 minus 0 divided by 2. So no matter it is plus 0 or -0, right? Eventually you have only one answer, which is -2. Okay, both are the same value, right? So which is -2. Okay, so if you want to write out, you can write out -2 and -2 lah. That means what? That means both of your roots are equal, has equal value. Therefore, you call it as equal root. Okay. All right. So how will your graph look like if let's say you're having real and equal root? Okay. So if you're having real and equal root, then your graph might look something like this. The U shape will touch the x-axis at one point only. All right. So this is the root. Okay. And then if let's say you're having M shape, same thing happen. You should know that your graph might look something like this. Okay, I didn't touch it. Sorry. Wait. Okay, so you should have something like this. Okay, and then you'll see that your graph actually touches the x-axis at one point only. Alright, so this is what we call as real and equal roots. That is square minus 4ac equals to 0. Okay? Alright, so now if you look at part number A and also part number B, part number A is real and different. Part number B is real and equal. So both of them are also real. Okay, therefore, when you combine these two together by looking only at the real part, okay, you have the last result here, which is b squared minus 4ac greater equal to 0. So when you have greater equals to 0, when you see the word real roots, but you don't know whether are they different or are they equal, then your conclusion is b squared minus 4ac greater equals to 0. So they actually combine the first two results together because of the word real. So if they only summarize for you, okay, this quadratic expression has real roots only, but they didn't say whether are they different or are they equal. So when you write out the equation, you should write as b squared minus 4ac greater equals to 0. Okay? Alright, so after that, we go for the third one. What will happen if let's say you are having b squared minus 4ac smaller than 0? Okay, so for smaller than 0, right? Generally, we are having complex roots or there's no real roots. Okay, so what does it mean? So maybe we can take the binomial formula again. X equals to -b plus minus square root. So they say b squared minus 4ac, they want it to be negative. Smaller than 0 means negative, right? How about let's say you put in -9? Okay, you put in a negative value for the b minus 4ac divided by 2. So if you try to continue, you will see that actually you cannot continue anymore because this square root -9 is a math error. So can you continue to get the answer or not? Cannot, because you cannot solve. You start here. Alright, square root -9 to us now, for it is math error. Therefore, you cannot continue to get an answer. So that's why there's no real roots. Alright, so for the graph, if let's say you're having quadratic expression with no real root, then your graph will not cut the x-axis. So it will look either like this, or it will look either like this. Okay, alright. So this is the very simple example on the summary of the nature of the roots. Alright, so again, I believe that most of you learned this before, and just this is just a very brief how to say the revision for you, call back what have you learned before. Okay. Alright, so let's have a look. How are we going to answer the question that related to all this? Okay, let's have a look for example 6. Alright, so here they give you a quadratic equation, right? Okay, so they give you a quadratic equation which is 2x squared minus px plus 8 equals to 0, and they tell you that the roots are equal. So when you know that the roots are equal, generally you should link it with b squared minus 4ac equals to 0. Equal, right? So if you refer to the summary on top, when you see the word equal, real and equal, means b squared minus 4ac equals to 0. And they want you to find the value of p. So again, what is the 2 here? The value of 2 is a. Number in front of x squared is a. Number in front of x is b, which is negative p. And then the last number here is the c. Therefore, when you want to find out b squared minus 4ac, it means it will be negative p and then squared minus 4ac. And you let it equals 0. Okay, so p squared minus 64, which is equal to 0 again. Alright, so what is the value of p? So p squared equals to 64. P, you need to take square root, right? So when you want to take square root yourself, you have to put the plus and minus sign. So which is plus and minus 64. And therefore your final answer of p, there are two values. Okay, so which is p equals to 8 and also p equals to negative 8. Alright, so there's a typo here. They should tell you that find the values of p, but not the value of p. Okay? Alright, so this is how we try to link the keyword, the real, the equal word, okay, with the discriminant summary. Alright, because I see the word roots are equal, therefore I start with b squared minus 4ac equals to 0. Okay, then let's have a look for a different question. Okay, so for example 7, it is slightly different from what we have in example 6. Example 6, you will definitely get an answer for the value of p, get a solution, right? Then for example 7, they want you to prove. Okay, so when they want you to prove, then maybe you need to be careful a bit. Right, so when they want you to prove, you cannot straight away start with the equation of the summary that we have, the summary of the equation that we have. Okay, you have to start with b squared minus 4ac and prove what they want you to show. Okay, so what they want us to show. So they want you to show that for this equation, they has real roots, whatever the value of k. So you see the keyword real roots here. So what's the meaning of real root? Okay, so real roots, you don't know whether are they different or are they equal, right? Therefore, the final answer that you want to prove as is you want to prove b squared minus 4ac is more than equals to 0. So this is the result for the real roots, right? Okay, so at the end of your solution, you have to prove that b squared minus 4ac is greater or equal to 0. Yeah, so let us start now. Okay, so I'm having b squared minus 4ac. Look at this quadratic equation here. What is a? A is k minus 2. What is b? B is 2. What is the c here? C is the negative k. Alright, so I start from b squared minus 4ac. Then what do I have is 2 squared minus 4ac. Okay, 2 squared is 4. And then plus, multiply and expand all the things here, you have 4k squared. Okay, and after that, you are having negative 8k, if I'm not mistaken. Alright, okay, then if you rephrase it, you'll see that, oh, okay, actually this is a quadratic equation, also a quadratic expression. So you should have 4k squared minus 8k plus 4. Okay, then now, maybe I can factorize out the 4 and then to make my quadratic expression looks easier. Okay, so this is your b squared minus 4ac. Okay, now your aim is to prove this one is always more than or equal to 0. Okay, so usually with any question, they want to prove that something is always positive, or something is greater or equals to 0, or maybe something is more than 0. When you want to prove that something is positive, generally you have to try to link your solution into something with square. What's the meaning of something with square? Okay, so you can have a look here. Let's say 4 is a 4. I don't do anything. But you can see that k squared minus 2k plus 1. I can actually factorize it, become k minus 1 and also k minus 1. And eventually what do you have is you will have 4k minus 1 square. Alright, so when you're having k minus 1 square, what does it mean? That means for this bracket itself, no matter what is the value of k, okay, the k minus 1 square is always positive. Correct or not? No matter you put the negative value here, positive value here, as long as the whole bracket you square it, generally you have a positive value. Okay, so no matter what is the value of k, then this whole thing is positive. Okay, so which means the 4 and k minus 1 square is always more than equals to 0. Okay, which is also b square minus 4ac greater and equals to 0. Then you can make a conclusion. The equation, alright, has real roots, whatever the value of k. Alright, so this is a bit different from, I believe this is quite different from the question that you learned before. I don't think that secondary school will cover this kind of question. Alright, they actually want the students to analyze a bit on their solution. Alright, so you can see that there's no final answer. That means there's no value like p equals to 8 is the final answer, right? But this one actually you need to make conclusion. Okay, so what I can tell you is if in the future when you want to prove anything that is always positive, always try to think the method so that in your solution you will have something like a bracket with square. That because anything with square, right, then that bracket itself with square is always positive already. That is very easy for you to draw the conclusion. Okay, so when you want to write the sentence here, again, if you, let's say you refer to the marking scheme of the parser, they won't tell you so detailed. They will just say that give marks for any relevant steps, or maybe any steps that is relevant or that is correct or something. Okay, but if let's say in exam you want to answer this question, generally you need to tell them why this bracket is always positive, and after that you need to try to link with the reason. All these are reason, and after that, conclusion. Okay, so this is what you generally need to do. Okay, all right. So this is what something new, okay, that we need to cover here. Okay, then if no problem, let us continue with another example. Example 8. Okay, so for example 8, okay, don't bother about this now. Okay, maybe I can do something here. Okay, so let's have a look for example 8. What's the formula? Wait. This is a formula. Sorry, I need to. Because just so I didn't realize that I write something here. It's okay. Okay, so this is our question now. Right, it is a parser question actually. Okay, so now for this example, also the same one, they want you to prove something. Okay, this is the equation that you have. All right, so they want you to show that the whole of the curve lies above the x-axis. I think this is x. They actually want you to show that your curve is something like this, lies above the x-axis. Okay. All right. So there are a few ways for us to solve this. Okay, there are a few ways. Okay, so the first method I will show is by using the concept that we learned just now. All right. So for the concept that we learned just now is discriminant, right? Okay. So method number one. All right, so for method number one, because we just learned the discriminant, therefore we are using a discriminant method, which is you try to find out the value for b squared minus 4ac. All right, so what's the value for b squared minus 4ac? You have negative 3 squared minus 4ac. All right, so negative 3 squared is a 9 minus 16, and therefore you have negative 7, which is smaller than 0. Okay, so you get b squared minus 4ac is smaller than 0. Okay, will this result, okay, enough, okay, or sufficient to prove that the whole curve lies above the x-axis or not? Okay, so please think. So a lot of students, they might think that, okay, after I get the b squared minus 4ac and prove that it is smaller than 0, then okay, the whole curve lies above the x-axis. So if you make the conclusion like this, then it is wrong. Okay, because for b squared minus 4ac smaller than 0, generally it means you might have two cases here. You might have this one, case number 1 or case number 2. Both are also b squared minus 4ac smaller than 0. Okay, therefore, if you only write out the b squared minus 4ac smaller than 0, it is not enough for you to prove that the curve lies above the x-axis. You need another extra information to prove. So what is the extra information? Okay, then you want to prove that you're having a U shape instead of the N shape. Understand us or not? Okay, you want to prove that your equation here is actually a U shape. How can you prove that it is a U shape? So you can actually write, since A is equal to 1, correct or not? A is equal to 1, which is more than 0, and therefore you're having a U-shaped graph. Okay, right? Therefore, y, or maybe you can write the curve lies above the x-axis. So in your step, if let's say you want to use the discriminant idea, besides b squared minus 4ac smaller than 0, you also have to prove that your graph is a U-shaped graph. Then only you can say or conclude that your whole curve is above the x-axis, lies above the x-axis. So this is the first method that involves discriminant. All right. Okay. So maybe some students will say, "Can I don't want to use the discriminant part?" Can. That's method number 2. So for method number 2, what we did is we will try to actually figure out the minimum point or maximum point for the expression. How to get a minimum point or maximum point here? So generally we need to do completing square. Okay, so what we have is negative 3 over 2 square minus negative 3 over 2 square plus 4. Okay, so if I look at this, I will have x minus 3 over 2 square, then minus 9 over 4 plus 4. And from here, okay, I try to divide the last term here, negative 9 over 4 plus 4. So I'm having positive 7 over 4. Okay, so we are applying the completing square method. Okay, so after you complete the square, you just need to show them that, okay, for this graph, you are having a U-shaped graph because you know that A, again, the A is positive, right? So you draw a U-shaped graph, and you also show them that what is the point here. So this point itself is 3/2. You show the vertex, and also 7/4. So since minimum point is 7/4, that means it is enough to prove that this whole curve lies above the x-axis. It cannot be down. Okay, because this should be a minimum point. So minimum point should be this one. Alright, and therefore we can write the curve lies above the x-axis. Okay, so please compare method number 1 and number 2. I believe that most of the students, they like method number 1. Alright, so I believe this, most of you actually like this. But again, if you want to apply the discriminant concept, then please make sure that you also prove this curve actually is a U-shape. That only you can make a conclusion here. The y lies above the x-axis. And then if you are using method number 2, to me actually method number 2, the completing square is more convenient. If let's say your concept on this is quite okay. Alright, so it depends on which one you prefer more. Alright, so if you can completing the square, you can straight away show them that this is a minimum point, the coordinate of the minimum point, and then straight away tell them the conclusion. Okay, so this is some questions that related to discriminant. Alright, so what I want to show you now is when you look at example 6, it is more the traditional type question that you learn in SPM maybe. Okay, and then when you look at example 7, the proving one, and also example 8. Okay, these two are actually the style of the question that will appear in A-level exam, the real A-level exam. They actually want you to prove something, so they are using your analyze. They actually want to know whether you stand well or not by having all the methods that you learned before. Okay, so all these are more on analyze to prove that, therefore you need to have reason. Okay, you must have valid reason, and then in your solution you must have the conclusion. So to me, this is the reason. These two are reason. Okay, and then this is the conclusion. Alright, so for method number 2, all the steps here are reason, and then this is the conclusion. Alright, so you always need to do something like this. Some students feel lazy, they don't like to write long sentences in the maths question, but you have no choice. In A-level exam, you might need to write out some sentences to clarify some steps. Alright, so like all this conclusion, everything you have to write out the reason and conclusion so that they actually can give you marks on all this. Okay. Alright, so this is what we have for the discriminant part. Okay, so we'll stop here for this video. And then for the next video, we are going to learn how to solve the equation in quadratic form. Right?